Python control flow part 3. Now we want to print only even numbers. We can just remove this part of the code, save it, start without debugging. So it has printed even numbers 2, 4, 6 and 8. We can as well say here pass to here and take this. So it will print 2, 4 and 6 and 8. 2, 4, 6 and 8. So we can use this pass statement, or we can just remove that else part. This pass will be useful when you want to write a function and then you don't want to use it now, but you want to use it in a future point of time. You can use this pass statement. This means ignore this part of the code. So that's how we can print even numbers. Now let us print some Fibonacci numbers. These Fibonacci numbers are in this series, like 0 plus 1. The previous two numbers, if you add them, you will get the third number. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is the next number 3, and 2 plus 3 is the next number 5, 5 plus 3 is the next number 8. That's how it will go on, the Fibonacci numbers. Let us use the while loop to print this series. So initially we are taken this x is equal to 0 and y is equal to 1, and we'll print Fibonacci numbers less than 100. So while x is less than 100, we are printing x. So we are printing the x is 0 and y is 1 we have taken. So we are printing x, and then we are taking a variable p and adding x plus y, because we want to add these two and then get the next number. So p is equal to x plus y. Now we are moving this y to the x to the y number. That means x is equal to y. X has become now 1 because previously y is 1. So now x has become 1. So it has moved from here. We started with x is equal to 0 and now x will be 1. And then y is equal to p. P is nothing but x plus y. That is this plus this would be p. So we are assigning y is equal to p, the next number. So let us execute. Now we have got 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. The same series, we have achieved it. So here what we have done is we have taken x is equal to 0, y is equal to 1. That's where we are starting. And while x is less than 100, we are looping through. So till x is less than 100, we have went there. So now we are printing x. So it will print 0, and then we have assigned p is equal to x plus y. X plus y is 0 plus 1 is 1. So that will be the next number. And then we have assigned x is equal to y. So x has become now 1. And y is equal to p. Y has become now p. P is nothing but x plus y. That is the next number, which is 1. Y has become p. So this loop goes on until x is less than 100. And we have seen that it has printed the Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Now let us print Fibonacci numbers with for loop. So here I have declared x is equal to 0, y is equal to 1, for z in range 1 to 100, printing x, and p is equal to x plus y. Just as in previous case, we have taken this p is equal to x plus y, and if y is greater than or equal to 100, then we are breaking out of the loop, and x is equal to y is equal to p. So here this is we are taken initially these two, x is equal to 0 and y is equal to 1, and we are looping for z in range 1 to 100. We are printing x, so we are printing these numbers 0 1 1, and p is equal to x plus y. So these two we are adding and getting the third number p. And if y is greater than or equal to 100, we are breaking and we are assigning y to x and p to y, so that it can go on. Let's execute this. Now if you see 0 1 1 2 3 5 8 13 21 34 5 89. So these are the Fibonacci numbers that we have printed using for loop. So we have seen both while loop and for loop in printing the Fibonacci numbers. Now let us print the prime numbers. Prime numbers are up to 100. These are the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. So let us print them. So for x in range 2, 100 and nested for loop, for y in range 2, x, if x mod y is equal to 0, then we break, else we print the x. So if if it is divisible, then that means if x mod y is equal to 0, it's divisible other than the number itself, then we'll get the remainder 0. So we are breaking at that point of time, then we are printing the, else we are printing the x. So it has printed 2, 3, 5, 7, 11, 13, 17, 19 and so on up to 97, because we have limited x from 2, 100. So that's how we can print the prime numbers.